Question number one, they tell you that BF is a median, and that means that BF connects vertex to midpoint to opposite vertex. So F is the midpoint of AC. So what that means is that AF and FC are congruent to each other. And that is answer choice number four, but let's talk about why the other ones are not correct. BD is an altitude, so all that means is it's a perpendicular line. So all it forms is 90-degree angles. None of the answer choices are about angles BDC and angles BDA, which are those two right angles. The next segment is segment BE, and segment BE is an angle bisector. So careful, answer choice three is incorrectly saying that E is the midpoint with CE being congruent to EA, but that's not true because BE does not bisect the side. BE bisects the angle. So from B to E would be congruent, and from C to E would be congruent. So let me put that in a different color so it's easier to see. So angle ABE would be congruent to angle CBE. And that's why answer choice number two is wrong because answer choice number two is saying ABF, but it's until E because BE is the angle bisector. And answer choice one, we don't know anything about the relationship between this angle over here and this angle over here. We don't know that this triangle by itself is isosceles. So answer choice four is the correct answer. Number two is changed because we already had the other question during class. So here is a new question for number two. So in triangle ABC, BD is the perpendicular bisector of ADC. Bisector, perpendicular. Based upon this information, which of the following can be proven? BD is a median. Medians do connect midpoint to the opposite vertex. It's a perpendicular bisector, so I know it's connecting the midpoint of the side. I know it's connecting to the opposite vertex because they named the perpendicular bisector as BD. And since the triangle is triangle ABC, B is one of the vertex points. So it is connected from vertex B from the name to the midpoint of side AC, which is D, because it is a perpendicular bisector. So answer choice number one is correct. BD bisects angle ABC. Well, let's see. Congruent side, congruent angle, shared side, congruent to itself due to the reflexive property. So we have congruent triangles due to side, angle, side. So using CPCTC, since we have congruent triangles, the corresponding angles here are also congruent due to CPCTC. So BD is bisecting angle ABC. Triangle ABC is isosceles. Well, let's see. Do the CPCTC, this pair of corresponding angles would also be congruent, but I have different markings on all my angles, so it's not really clear. So let's talk about the sides. Do the CPCTC, the corresponding sides would also be congruent. And this tells me, this might have been enough for you over here with the angles, but this for sure tells me that triangle ABC is isosceles. It's got two equal sides. It also does have two equal angles, but it has two equal sides. Our first step is to group x and y terms so they're next to each other. And the constant is already on one side of the equal sign, so we're going to leave it there. So we have x squared plus 12x plus whatever is going to go in the box to make it the trinomial plus y squared. Wait, there's no term that just has a y. So that means we can represent it as 0y because if it's not here, then 0 times anything is just 0, right? So it doesn't actually exist. It's just a placeholder. And then on the other side, we have negative 27. And remember, whatever we add to the left, we also need to add to the right. Remember, the easy way that you can find the number that will make this the perfect square trinomial is by doing b over 2 squared. So we can do 12 over 2 squared, and that is 6 squared, which is 36. And remember, the really easy trick is that since this is a perfect square trinomial, it's going to factor to something repeated twice. And that something is your b over 2 before you squared it. Since b is 0 here, b over 2, 0 over 2, 0 squared is just 0. So 0 is the number that completes the square. And that just means 0 goes here. So on the right-hand side, all we have to add together is really negative 27 and 36, which is 9. And now we have it converted into the correct format. Remember, when you're pulling out the center from the circle equation, it's opposite sides because that's the circle equation has the built-in negatives. The circle equation is x minus h squared plus y minus k squared equals to r squared. So it's got those built-in negatives. So pull out opposite signs. There is no negative 0. So I just pulled out 0. And the radius, so r squared is 9. So the radius is radical 9, which is 3. So negative 6, 0, and 3. Be careful of the negatives. That's why you should write out all your steps with the b over 2 squared. Because notice how the answer choices are every single variation of negative and positive. These are some review questions on quadrilateral properties. If we have quadrilateral best, which would not be sufficient for proving that it's a parallelogram? Let's take a look. The first one is BD congruent to ST. So that's the diagonals. BD congruent to ST. Oh, sorry, BD congruent to SD. I can't read. And ED congruent to TD. This would prove that we have a parallelogram because diagonals bisect each other is a parallelogram property. BE congruent to ST and ES congruent to TB. This would prove that it's a parallelogram. Both pairs of opposite sides being congruent is a parallelogram property. ES is congruent to TB and BE is parallel to TS. This would not prove it's a parallelogram. It's not one pair congruent and one other pair parallel. It's one pair that is both congruent and parallel to prove it's a parallelogram. And actually, the next answer choice is both pairs of opposite sides parallel. So that one is a way. So if the congruent was also on BE and TS, it would be good. Or if the parallel was also on BT and ES, then it would be good. But right now, it's not a way to prove it's a parallelogram. It's one pair of opposite sides, both congruent and parallel. Now we already know that we have a parallelogram. And the question is, which information is sufficient to prove a rhombus? So we need to prove a rhombus property. Number one, EA perpendicular to AT. That means a right angle would be formed here. Nope, that's a rectangle that has corner angles that are right angles. EA congruent to AT, this is a rhombus property. If consecutive sides of your parallelogram are congruent, that means it is a rhombus because since it's a parallelogram, opposite sides are congruent, so all the sides are congruent, so it's equilateral. Oops. We can try out the other answer choice. Let me just make sure I didn't delete the page here. Okay, we can try out the other answer choices as well, but this is the correct answer over here. ET, congruent to AK. No, that's a rectangle that has congruent diagonals. And 4, ET, congruent to AT. That one doesn't even make any sense. Okay. Number 6. For the next one, we have that AB is 26. We have that AC is 28. And we have that PC is 16. And we need to find the perimeter of triangle CZA. So we need side CZ, we need side AZ, and we need side AC. We already have side AC is 28. We know that we have medians here, so Z is a midpoint of the side because ZC is the median, and medians connect midpoint to opposite vertex. So that means that this side over here is 13. And since ZC is a median, and medians are in a 2-to-1 ratio, PC is the 2 part of the ratio, so that means PC is the 1 part of the ratio, being 8. So that means the whole segment is 24. ZC is 24. So we have 24 plus 13 plus 28. And that is 65. For the next question, we have to determine what sequence of transformations occurred. So if we're reflecting triangle AC over the line y equals negative x, so what that means is it means a decreasing line with a slope of 1. And already I might be able to tell if this is going to work or not going to work. But just to be absolutely certain, sometimes it's hard to count side distances. We know the rule for y equals x reflection is that we switch the x and y coordinate. Very similar to y equals negative x. You swap the x and y coordinate and you negate it. So I'm going to just try with one point. Point A is 1, 2, 3, 4, 5, 6, 2. So that means A prime after a reflection over the line y equals x be negative 2, negative 6. Negative 2, negative 6, that's not where it is. So this is not the answer that we're looking for. Reflection over the line y equals negative plus 2. So for that one, it has a y-intercept of 2, and it's got a slope of negative 1. And I'm just going to graph a couple of points just so we get an idea. But what we can see is that if we're reflecting over this line, even if we don't know exactly where A is going to fall, it's going to fall somewhere on this side, right? Because it's a mirror image. It's not going to land over here. So I don't think a reflection is the way to go here. If we need to move A landing over here, I think that's going to be more of a rotation that's going to occur. So we have 2 rotations that it's asking us about. Asking us for a rotation centered at the origin of 180 degrees or rotation centered at the point 1, 1. And the point 1, 1 is right over here. So I'm going to try out the answer choices in order. We're going to see. So if I connect 1, 1, that's 1, 2, 3, 4, 5 this way, and 1 this way. And I'm going to go through it so I don't make a mistake here. So the L shape looks like this. And it's counterclockwise if it doesn't specify. So 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go, kind of like a clock. So clockwise is this way, counterclockwise is this way. So if I rotate this L shape 90 degrees counterclockwise, gonna look like this. Stand up clockwise. And if I rotate it again, and you might have realized that it doesn't even matter if you're rotating clockwise or counterclockwise because 180 degrees is the same in both directions. So that means what our L shape should look like is the long part should be this way and the short part should be this way. So let's check it out and let's see if that's the case. So 5 and 1. 1, 2, 3, 4, 5, and 1. And that absolutely works. So that is the correct answer choice. Centered at the origin, it would be a little bit off. But you can always check it out by connecting from the center of rotation to the pre-image point, and then seeing if it's going to land in that spot for the image. And I'll try out the last answer choice so that way you can see it. So I'm going to try out the last answer choice and show you how to do it in case you want to see. That would be helpful for other questions as well. So if I'm rotating around the origin, that's my point. And if I connect to pre-image point, 1, 2, 3, 4, 5, 6, 2. So just like before, if I rotate it 90 degrees, the L shape is going to look like this. 180 degrees, the L shape is going to look like this. So from the center, 1, 2, 3, 4, 5, 6, 1, 2. Notice how it does not fall where A prime is. So that's not the correct answer. So answer choice 3 is the choice that we are looking for. When we're writing the equation of a perpendicular bisector, a perpendicular bisector cuts in half, so it passes through the middle, and it creates right angles, so it's perpendicular, meaning it has opposite reciprocal slopes to the original line segment. So I'm going to start with negative 5 plus 7 over 2, 1 plus negative 9 over 2, 1, negative 4, now our slope is usually labeled as y2 minus y1 over x2 minus x1. Negative 10 over 12. If I reduce that, it's negative 5 over 6. So the perpendicular slope would be positive 6 over 5. The equation of our perpendicular bisector in point form is y minus y1 is equals to 6 over 5 x minus 1. And if the answer choices were multiple choice and they were in y equals mx plus b form, all you need to do is distribute in order to solve out. I can show you that real quick at the top, just as a side note. So y plus 4 equals to, if I were to distribute, 6 over 5x minus 6 over 5. Once again, this is just the answer choices were written this way. And then on your calculator, it's subtract 4, so that would be negative 6 over 5 minus 4. And you can do that on your calculator. Your calculator is really good at adding and subtracting fractions. And you can always hit math enter to change the decimal to a fraction. I'm not going to use the grid here because it says the use of the grid is optional. 3 to 2 ratio means 5 parts in total. And since it's a 3 to 2 ratio, that means is the 3 part going to be here, then there's going to be the point, and then there's going to be the B part, and then there's going to be B. So that means the point's going to be closer to B, so B needs to be weighted more heavily. So that means A is going to get a smaller fraction. Oh, sorry, there's 5 parts. I almost just did a mistake there. And B is going to get a lower fraction because it's going to be weighted more heavily. So I'll just separate it with the x and the y coordinates. So the x coordinate from A is going to get 2/5 fraction, so that's negative 2. And the x coordinate from B is going to get the 3/5 fraction, so that's 8. And you can stick that into your calculator with that negative 4 over 5 plus 24 over 5. So that's 20 over 5, which is 4. Okay? And And now for the y coordinate from A gets the 2/5 fraction is A is multiplied by 2/5. And the y coordinate from B gets the 3/5 fraction. And you can use your calculator for this. That's 10 over 5, and that's negative 3 over 5. So that is 7 over 5. So our coordinates of our point are 4. Make sure you put them in the right order. That's how we're separating it. 7 over 5, which you can also write as 1.4. And we should always just double check whether our answer is reasonable. So I'm going to graph it just to check that the answer is reasonable. Negative 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, that's 2. And we know that the point should be closer to B than A, but it shouldn't be like right on B, right? There should be the 2 part closer to B and the 3 part closer to A, but it should be closer to B. And the point that we found was 4. 1, 2, 3, 4. 1.4. Yes, that's definitely reasonable. So even if you get scared if your answer doesn't look right, just check if it's reasonable, right? You don't have to use the grid to solve, but check if it's reasonable using the grid if you have one. Moving along, we need a line that's parallel to this one. So I can't see the slope and the y-intercept right now because it's not in y equals mx plus b form. So the first thing I'm going to do is I'm going to solve the original equation for y. So I'm going to isolate the y by doing the term away from it, it's positive 2x, so I'm going to subtract that. But sum of this negative 2y equals negative 2x plus 11. The negative 2x and the 11 combined, which is the negative 2x. And then we're going to divide everything by negative 2. Get the y by itself. So what we have is y equals to positive 2 over 3x minus 11 over 3. Negative divided by a negative makes a positive. Positive, negative divided by each other is a negative. So you can just write it like that a lot easier. The only thing we care about for writing the equation of the parallel line is the slope. We need the same slope of the parallel line. So we're going to be using the same slope of 2 over 3. I know we're used to opposite reciprocals now, but this is asking for parallel. Make sure you read the question carefully. It doesn't also pass through this point. So I'm going to go to the point slope form. Y minus the y coordinate of the point. The slope x minus the x coordinate of the point. And there we have it. Once again, if this was a multiple choice question and the answer choices were y equals mx plus b form, you could just distribute the 2/3, solve for y. Okay. We need to find the area of this triangle. But from this triangle, maybe we could find the length of the base using distance formula. The height, the altitude is not a clear line. So I might not be able to find the length of that line because notice that even though if I connect from here to here, this is not a straight point. I don't really know exactly what point that is. So what we can do instead is the strategy where we go from vertex to vertex and do dots. Right. I'm going to go from vertex to vertex. So I'm doing that. And dots the vertex with. Here we go. Dots it. And notice how what's formed around the triangle that we want the area of is 1, 2, 3 right triangles. And right triangles are nice because you can find the area using 1/2 distance, right? The second right is simply just the legs that you can just count because they're horizontal and vertical lines. So I'm going to find the area of triangle 1. 1/2 is my height. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So half of 9 times 4. That's half of 36, which is 18. Now I'm going to find the area of triangle 2. 1 and 1/2 is 18, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So half of 18, 2. So that's half of 16, which is just 8. 8 times 2 is 16. And finally, 1 half of 28 is 14. So if I take the area of the whole box and subtract off the areas of these rectangles, I'll be left with the area of the inner triangle, which is what I want. So the whole box is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. It's a 9 by 8 box. So the area of the whole is 9 times 8 times 8, which is 72. So I'm going to take 72 and I'm going to subtract off all of the areas to the right. The 18, the 8, and the 4. And let's see what I get. So I'm going to subtract 18. I'm going to subtract 8. And I'm going to subtract 14. And I get 32. So 32 units squared is its area. Is the area of my triangle. Okay. We need to describe a sequence of motions that's going to map triangle ABC onto triangle DEF. So I like to avoid rotations when possible. Even though you might like rotations, I like to do reflections. So I'm going to actually probably do a double reflection. I need A to map onto D. I need B to map onto E. And I need C to map onto F. Oh, so this looks like a good situation for a rotation, actually. But as I said, I don't really like to do those. I'm going to try to do a double reflection first. I'm going to reflect over the y-axis first. One, one, just putting it equal distance. One, one. You would go over here. One, two, three. One, two, three. Another 2 units away. And then let me try to, no, that wouldn't work. So I guess a double reflection is not possible here. Just X and Y axis, which is what I wanted to do. So I'm going to do a rotation. To me, it looks like 90 degrees, and then we can flip it. Let's see. If we rotate it 90 degrees, it would go here. C would go somewhere over here. Oh, so it looks like we're going to do next time. We might be able to just do a 90-degree rotation and then translate it. Try that. Let's try 90 degrees around the origin, and then we can translate it. Okay. So here's the origin. And I'm going to rotate point B first 90 degrees. So that looks like motion this way. So if I rotate it 90 degrees, I'm going to go this way. I'm going to rotate it clockwise. It's going to look like this. So 1, 1. It's going to land right over here. Okay, let me try the next point now. I'm going to connect A. I'm going to connect A. The side. 1, 2, 3, 4, 5. 1, 5, and 1. And let me erase these shapes because I'm going to use the new one. So it looks like this. And I rotate it 90 degrees. Clockwise. I'll look like this. So the long part's going to be here, which is 5, and the short part here, which is 1. So 1, 2, 3, 4, 5, 1. Okay, so far because E prime and A prime are on the same line here, and they're 1, 2, 3, 4 units away. 1, 2, 3, 4 units away. So I'm preserving the distance in the point. So far this is looking good. Okay, let me try the last point. And I like to take my time with rotations because otherwise I'm going to mess them up. Okay, and I don't have the rules memorized, so I do that. So 1 this way, 1, 2, 3 this way, and that looks like this. So if I rotate it here 90 degrees clockwise, no, sorry, clockwise, it's going to look like this. So short part here, long part here. So 1, 1, 2, 3. And could be prime and C prime are on the same line segment as BC, and there's the two spaces in between them. Oops. I wanted to put a line. I was moving all my points. Okay, so that looks good. Let's make sure the things match up. A needs to match up with B. B needs to match up with A, which it does. C needs to match up with F, so the orientation is good. So aside from this, all I'm going to need is a translation. So let's see how I need to translate. I'm just going to one of the points. We'll just take A and see how A needs to map onto B. So that's 1, 2, 3, 4 down, and 1 to the right. So I'm going to write this out. Rotation 90 degrees clockwise around origin, followed by a translation of 1 unit to the right and 1, 2, 3, 4 units. You don't have to use notation. You can literally write that out 1 unit to the right and 4 units down. Okay. As you can see, sometimes it requires some thought. And at first, I was thinking you could do a double reflection over like the x-axis and the y-axis or the y-axis and the x-axis, and that didn't work. You should always try it out using the grid. You don't want to like eyeball it and be wrong because it happens all the time. Okay, for this one over here, I'm gonna graph real quick. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 1, 2, 3. 1, 6, negative. Okay. How does D have the same point? That's incorrect. Oh, it's not the same point. It's negative 6. 1, 2, 3, 4, 5, 6. 1, 2. Let me make sure I got this right. 1, 2, 3, 6. 6, 3. 6, negative 2. And negative 6, 2. Okay. In my mind, I was not picturing how that trapezoid was going to look. Okay. We need to prove that ABCD is an isosceles trapezoid. Before it could be an isosceles trapezoid, it had to be a regular trapezoid first, right? By definition, a trapezoid has one pair of parallel sides, and it's always going to be the bases. So I'm going to find the slope, AB, and I'm going to do it really quickly using y2 minus 1 over x2 minus 1. There we go. I'm going to find the slope of BC, and I should expect it to be the same. Negative 2 minus 3 over minus 6. That's not a vertical line. It doesn't look right. It did not work out to 0. Let me try BC again. It's right. That's not BC. That's right. That's BC. I tried to label. I labeled and I still was looking at the wrong side. BC is the name of the side. Okay. Let's try that again. 2 minus negative 3 over negative 6 minus 6. That's 4 over negative 12. And that is negative 1/3. It doesn't matter if your negative is in the numerator or the denominator, it's the same. Because it's something positive divided by something negative. So I just pull it out and put it most of the time. It's the same thing, it's just a negative number. Okay. So since one pair of opposite sides are parallel, ABCD is a trapezoid. And you can say instead, since the bases are parallel, the trapezoid. We used to also show that these do not have the same slope, show that trapezoids only have one pair of parallel sides, but it is enough to show just that this pair is parallel because there is mathematical debate that whether a trapezoid only has one pair of parallel sides or has at least one pair of parallel sides. So this is enough. Okay, so now proving that it's isosceles. So you can prove either the leg congruent or you can prove I'm going to just do the length, I guess. So with that AD, so I'm going to find the length of AD using the distance formula real quickly. Right, 2 minus negative minus positive 6. When I mix and match those x's and the y's, so easy to do that. So that is 3 squared is 9. Just on your calculator, please. Just again with something radical. Don't type in the whole radical, just with something radical. Okay, and now I'm going to find C, and I'm going to hope for it to be the same thing, because otherwise I did something wrong. 6 minus 6 squared plus CS, and negative 2 minus 3 squared. So that's pretty fine. 0 plus 25, radical 25, so 5. So just make sure you write your concluding statement. Legs are congruent, trapezoid ABCD is isosceles. There we go. Now finally for the last question. So this grid's not going to be helpful here. Let me just look at these coordinates. It's very large. I don't know why every time there's supposed to be a negative of 2 got placed there. Sorry about that. You're going to have to make that correction on your review sheet too. But we'll let you know that in class. So we're going to prove that angle PET is the right triangle. And I'm going to just type in the graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 1, 2. Okay. So now we're going to prove that this is a right triangle. So it's a right angle, we're going to use slopes, and we're going to show that line perpendicular. So I'm going to go into slope. PE. I see PE and PP are going to be more than equal. So PE 8 minus 4 over 6 minus negative 6. And now I'm going to find the slope of PP. Negative 2 minus 4 over negative 4 minus negative 6. And wonderful, they work out to be opposite reciprocal slopes. Then we have opposite reciprocal slopes. PE is perpendicular to VP, so they form a right angle, making PEC a right triangle. State the coordinates of N, the image P after a 180-degree rotation centered at 1, 3. 1, 1, 2, 3. There we go. So let's do the 180-degree rotation of point P. I'm going to connect point P to the center of rotation. I would do this in pencil so that you can erase it afterwards, okay? So it doesn't matter what direction for 180. So that's the L shape. And I'm going to just go around this way, the counterclockwise direction. So this would be the L shape after the 90-degree rotation. And this would be the L shape after 180-degree rotation. So the small part is 1. The long part is 1, 2, 3, 4, 5, I'm going to start at the center and I'm going to count. I'm going to go movement down, then across. One down, one, two, three, four, five, six, seven. Sorry, I messed up. Okay. So first I'm going to do the 90, and then I will do the 180 so that I don't get confused over here. Okay. So let me do the 90 first. So for the 90, from the center over here, we're gonna go over this way and then up this way and then over. Finish circle. So one, two, three, four. Sorry. One, two, three, four, five, six, seven. Good. Good. And then one, two, three, four, five, six, seven. And then one over. So seven, one, two, three, four, five, six, seven, and then one over. That's a 90-degree rotation of point P. And now we want to rotate P prime, and I'm doing it slowly. So I did the 90 degree, no need to rush it here. And now I'm going to do the 180 degrees separately, okay? Instead of trying to do it all at once. I was trying to do it at the beginning. Oh, sorry, I deleted the point. That is, I don't want to delete that point. I got it, because we just went through all that trouble to find that point. There we go. Okay. One, one, two, three. I'm going to put the center back, and I'm going to connect from point A to the center. And then it is going to look like this, because right, we have this currently. And if you rotate it 90 degrees, it will look like this. Remember, it doesn't matter what direction because 180, both directions is the same. So the short part done. 1, 2, 3, 4, 5, 6, 7. The long part 7. That makes sense because that shouldn't change. So I'm going to start at the center and I'll go down by 1. And I'll go across the 7. 1, 2, 3, 4, 5, 6, 7. So my original movement actually worked. I was doing. I just got confused and like started second guessing it because it is going to land over here where I originally thought it was going to land, and I'll walk you through it again. And this time, since I know that I'm not going crazy here and it's going to land there, I'll do it in one step. But definitely feel free to break it up into steps. One, one, two, three. If I connect from point P to the center of rotation, this is my L shape. And if I have it rotated 90 degrees in any direction, one possibility I think like is this. If I rotated it this way. And then if I rotated it another 90 degrees in the same direction, like this. So this is going to be my movement, rotate 180 degrees from the center, point P. Across this way is 7, down this way is 1. So the short part, 1, 7, because it's going to preserve the distances for this motion. So 1, 1, 2, 3, 4, 5, 6, 7, right here. And that is the same place that it landed before when I broke it down into steps. But I think it's good that we saw it twice anyway. Second time was definitely a lot less messy than the first time. So the coordinates here are 8. So correct answer for part 8 is, oh sorry, point N, not P prime. Don't label it as P prime. And you'll get confused with the next part. That is point N over here. So let me just put my labels back. That was point P. I just deleted it by accident. That's point E. So now we have 4 points. And if I connect here, we do have quadrilateral PENT, which our next goal is to prove that it is a rectangle. So first I need to prove it's a parallelogram. And in order to prove it's a parallelogram, I already have slopes of PE and PT. I'm just going to find the other two slopes, EN and TN. So I'll just do that here. Slope of TN, and that should be the same as PE, opposite side. So point T, I'll just take between negative 4 and negative 2, so I can just easily subtract the points. 2 minus negative 2, or 8 minus negative 4. So that is 4 over 12, which is 1/3. And look, it's the same as here, which is awesome. Okay, and then we need the slope of EN. I should expect to be -3 because it's across the PE. So the slope of EN, you would say, just I could say it real easily here, um, 2 minus 8 over 8 minus 6, and that is -6 over 2, which is -3. So that worked out the same. So I'm going to just write my concluding statements here. Both pairs of opposite sides parallel. PENT is a parallelogram. We already showed that there's a right angle in part A. Since a parallelogram with a right angle is a rectangle, PENT is a rectangle. And there we go. We already have the word that shows rectangle because we already showed that there's a right angle in part A. We already showed the opposite reciprocal slopes between PE and PT. So we already showed that, now proved it's a parallelogram, and we already showed that there's a right angle right over here, where PE, oh sorry, where PE and PT intersect. We showed that there's a right angle here. Not that it matters, as long as we show the presence of one right angle in our parallelogram, we know it's a rectangle because that means that all the angles in the parallelogram are rectangles because opposite angles are congruent in a parallelogram. And consecutive angles are supplementary, so all of them would have to be right angles if we know this is a parallelogram, which we do because we just proved it, showing opposite sides of parallel. So we showed opposite sides of parallel to prove the parallelogram, and the presence of a right angle to show it's right.